All right, well, good morning, everybody. Thanks for joining us this morning. The focus of the research I'll be presenting today is pretty much looking at can we do a better job planting a small grain crop like winter wheat, right? Compared to the technology that we are using in other crops, in corn and soybean as an example, right? And this is critical because we are setting that yield potential when we are planting our crop. And then we are trying to protect that yield potential by doing optimal weed control, fertility, and other aspects, right? As other speakers will talk about. So in this project, we're pretty much looking at that piece that uh, is the new technology giving us an advantage in terms of doing a better job at the time of planting. Our overall goal here is essentially looking at designing this canopy that can maximize the yield potential by intercepting as much sunlight early in the growing season as possible, and then converting most of that sunlight into biomass and eventually grain yield, right? There are multiple ways to get to that point, and we are looking at multiple components of this overall research, starting with seed placement, and I will come back to that, as well as looking at row spacings, seeding rates, even variety selection in terms of genetic differences in the varieties that we have, planting times. So all of these agronomic decisions are part of this overall goal to design that canopy. And I'll be touching on a subset of these in the research that we are doing at this point. The main focus for us is looking at the seed placement idea and essentially asking the question, can we do a better job compared to the conventional drills that have these rotating gears and can result in this controlled spill, so to speak, that might not give us an optimal seed placement, right? Just as an example, we are using this vacuum plate system planter where it does pick that individual seed one at a time and drops down that tube, right? So just one example. There are other examples out there. Industry is working at some of this new equipment, but I believe we are still at the beginning phase of this. What do I mean by that uniform seed placement, right? That's what I talked about before. So to me, there are two components of this: planting depth and that seed to seed spacing, what we call singulation. So planting depth is important. Variable planting depth, as you can see in this picture right now, that can occur from using a seed drill can result in poor germination and crown root development. And that might result in non-ideal tillering for the plant and can influence our yield potential. Similarly, non-optimal singulation in terms of skips and doubles can also cause that non-ideal canopy development that can minimize our yield potential. So this example is if we are using a seed drill. Now let's see what happens if we were to use a better technology. Here, as you can see on the right, we are able to achieve more uniform planting depth and that uniformity of seed to seed spacing. So that's the idea we are trying to achieve. So again, the target is twofold. Looking at that uniform planting depth, as you can see on this picture in the left, and it's leading, that seedling in the middle is leading to that optimal plant growth and development, as well as this singulation, what you can see on the picture on the right. And our idea is again that this will lead to more uniform tillering capability for the plant and then more uniform canopy development. And that might help us with the various agronomic management decisions. For example, fungicide application for head scab management, right? If the canopy is flowering at the same time uniformly, we might get better efficacy out of that. But the question is, are we there yet, right? And that's what we're trying to answer. I have a quick video here that I'll try to play here. And here you can see, as we are using this plate planter, that we are able to drop this one seed at a time, and hopefully that gives us that capability to have that uniform seed to seed spacing. So looking in terms of our project objectives, first we are comparing our seed drill to a precision planter in that 7.5-inch row spacing, right? That's what we set up with the seed drill. You might be thinking that how does that singulation going to benefit if we're just putting seed on top of each other? As you can see in this picture, at 2 million seeds, the seeds are pretty much on top of each other. So one idea we have is that can we cut down on the seeding rate using 1 million as an example, and now we have almost an inch between our seeds, right? So that's our first objective. The second question we're asking is that with the planter, we can even tweak our row spacing. So is there a benefit in going to a narrow row spacing? As an example over here, by going to 5 inches, we almost have 1.5 inches between those seeds. Are we going to benefit from that? Or what are the consequences of going to a wide row spacing? So those are the questions we are trying to answer. We have done this trial 2 years now, including a preliminary year. So that would be a third year. At 2 locations here on campus and Bean and Beet Farm. And again, comparing that drill versus a planter in 1 row spacing and then multiple row spacings for that planter, going all the way to 5 inches up to 15 inches. That some of the growers who have the equipment can do at this point, and using multiple seeding rates from 500,000 all the way to 2 million seeds. Looking at some of the results that we are seeing based on the first year that was wrapped up in 2019 and some pictures from this year. So here, beginning with that seed placement idea, you can see that by using that drill, here are some seedlings that we pulled out in the fall, and you can see that our planting depth was not uniform. You can see that the length of mesocarpal and the coleoptile is variable in here. And as well in the picture on the right, you can see our tail ring is, you can see that main stem is coming at a little bit deeper depth compared to everything, all the other tellers in here. And that compared to our planter, where in this picture, you can see more uniform length of that coleoptile, alluding to that uniform seed depth we were able to achieve. You can see that optimal tail ring in that picture on the right here. And this did translate to some data that I'm presenting here. All we are looking at is the variability in that seed to seed depth on this figure. And by using that planter, we were able to reduce that by 60%. So that's a lot of reduction, right? So we were able to really get to that uniform depth using that planter. In terms of the seed to seed spacing, we did reduce it by about 17%. But that is not where we want to be. I believe that again, with the new technology, we can even improve upon that number. But we are seeing some benefit in terms of, again, seed to seed spacing, but more so on the seeding depth. And that did translate into yield differences coming from, again, 2019 data, that for 2 of our locations, Mason and Bean and Beet Farm, we saw anywhere from 9 to 15 bushel increase in yield by using that planter compared to a seed drill. And that we believe is again coming from that optimal seed placement that result in improved plant stand by about 25%. And we saw an increase in kernel weight in the plots that we planted with the precision planter. So that's where we believe part of this yield improvement is coming from. So this was again our first objective, comparing that drill against a precision planter, and we are seeing a yield benefit, right? So moving on to that second objective, where now we are trying to see that can we tweak our row spacing to achieve even a higher yield potential. So on this picture, you can see that 7.5 inches is where we started, right? At 1 million, we have about an inch between those seeds. What if we change that row spacing to narrow or wider? By going to narrow, we almost have 1.5 inches now. But if we go to a wider row spacing, we are coming back down to about 1/2 inch seed, 1/2 inch between those seeds, right? So again, trying to understand what a change in row spacing will do on top of that improved seed placement. Some pictures here that we took back in early May this year from our plots. So this picture is showing a 7.5 row inch spacing here, and we are seeing a 76% canopy cover. So early May, we are seeing again about a 3/4 canopy cover, which is pretty decent, right? But when we moved to 5-inch row spacing, we were almost higher than 90% crop cover, right? So that's showing you the about 15% increase in canopy cover just by going to a 5-inch row spacing early in the growing season. So it goes back to our idea of designing that ideal canopy that can intercept more light early in the growing season to get us to a higher yield potential. Our 10-inch row spacing was actually pretty similar to that 7.5-inch row spacing. When we went to the 15-inch spacing, we lost that canopy cover, only about 65% canopy cover, right? So this is early May, and we took those same pictures here just a couple of days ago here, June 8th. And here you can see the 7.5, 5, and 10 inches. All of them have pretty much more than 95% canopy cover. So the canopy did close. In 15 inches, that was not the case. We were still about 3/4 done. So we are losing that light interception with that wider row spacing here. So what does that translate in terms of the data, the yield that we are seeing? So here is our first location data from last year. It was planted a little bit late in the growing season because of the wet beginning, if you remember from last year. I have my 5-row spacing, including that drill on the x-axis. And the 4 different colors denote our 4 seeding rates, going from 500,000 all the way to 2 million seeds per acre. What we are seeing here is that in that narrow row spacing, we are able to push to a higher yield potential as we increase our seeding rate. Most of the other row spacings did not respond to increase in seeding rate. And you can see the difference in yield potential here, that our narrow row was able to achieve the highest yield potential compared to all other row spacings that we have used here. Looking at the same data from the bean and beet farm, similar trends. You can see 5-inch row spacing yielded highest compared to the other rows, at least similar to 7.5 using that planter in this case. But then we lost yield as we went to the 10 and 15-inch row spacing. Interestingly, the seeding rate response was not here in this location. And probably because we were able to plant relatively early in the growing season at that location. This to me was pretty interesting slide. So I compiled all of the data from 2019, both locations, and I regressed my row spacing, which is on x-axis, against my yield potential on the y-axis. And you can see this quadratic response of increase in yield as we went to that narrow row spacing, right? Just for comparison, at 7.5-inch spacing using that planter, we are able to get to about 113 bushels per acre. That compared to a 5-inch row spacing, 125. So we improved that yield potential by about 10 bushels right there. Going back to the 10-inch, we are about 100. So we lost some. And then down to that 15-inch row spacing, we have lost further. Now we are down to that 90 bushel per acre. And remember, our drill was about 100 bushels here. So you can see where all of our row spacing yield potentials fall based on this 2 location data from first year. And we'll update this based on the results we will be seeing this year. So here you can see a potential of improvement in yield by using that more precision technology and adding that with the benefit of going with the narrow row spacing. As I showed in those pictures, we are able to close that canopy earlier in the growing season. And that's probably also helping with some of the weed control with that narrow row spacing that we typically see in soybeans. And there is probably a soil moisture conservation factor going on with that narrow row spacing as well, right? Along with this, we are again also trying to improve the tiller management, as I have talked before, how we can optimize our tillering by using this new planting technology, that we are able to get enough primary tillers without getting any secondary tillers that won't have their own root system. And I have 3 seeding rate pictures over here, low, medium, and high. And you can see the difference in tillering capacity between those. We also took some biomass samples, and what we were finding out was that at the both low and high rate, our harvest index, which is essentially proportion of grain in the total biomass goes down at both low and high seeding rate. So there's probably a sweet spot somewhere in that middle range of anywhere from a million to 1.5 million, where we optimize the grain production relative to the total biomass that we are able to achieve. So to wrap things up, we are seeing a benefit of improving that seed placement in terms of, again, uniform seeding depth as well as seed to seed spacing. It's leading to more crop uniformity and an overall increase in yield potential for us. So we got to be thinking about how we can use our current equipment or the new equipment that might be at our disposal to improve that seed placement, right? We are seeing a potential for reduction in seeding rate below that 1.5 million without limiting yield and probably saving some input cost in terms of that seeding rate. We are also seeing a significant response of increase in yield by going with that narrow row spacing, probably on its own, and in combination with that improved seed placement. And it's probably going to lead to, again, better weed control as well as hopefully some soil moisture conservation. So the idea is that what we can do right now, right? Either we can optimize the current planters that we might have and try to plant in that narrow row while achieving a better seed placement. Or we got to be thinking about investing in new planting technology with some help and interest from the industry to invest in these equipments that can be used for multiple crops, right? You can probably use that same planter to plant soybeans and wheat and maybe other small grain crops. So that's sort of the idea here. We'll have this information at our website, which is listed right here on the slide. And we'll update our results based on this year's data. So please check that out. And with that, I would like to acknowledge everybody who's involved in this project and Michigan Wheat Program for their funding support, as well as Michigan State University. And we'll be happy to take any questions.
Thank you, Manny. I have not seen any questions come in yet, but again, remind people, if you click on chat and raise your hand, maybe we can get a live question in, and also, type it in the Q&A box. So I think we have one here. Oh, maybe not. No. I guess I have a question, Manny, when you have a minute.
Sure.
You talk a lot about spacing and row width, but we also, I think you've seen some increase with uniform depth of seed placement. So which priority do you think gets the best return? It would be the consistent depth placement, or would it going to a more even spacing, narrow spacing? Obviously all three would be better, but if you were going to invest money, where would you invest your first dollars?
Yeah, that's a really good question, Dave. So something that I and my grad student Calvin, who's leading this project, we have been talking about this. To me, if you remember that figure I showed towards the end, where I'm showing the regression between row spacing and our yield potential, I think that's a really good starting point. If we can figure out a way to narrow our row spacings, to me, I think that in itself is giving us an improvement in yield potential. And there is some research data available on that row spacing just using a seed drill, where they are seeing that improvement in yield potential, both here in the US as well as in some of the European systems. So to me, that's the first point. Number two, I would say, again, I think that we can, again, combine that narrow rows with the improvement in seed placement. So within seed placement, I think the low hanging fruit is that optimizing seeding depth, because that does drive your tillering capability. So to me, if we can optimize that seeding depth, we are going to see a benefit, and we can probably achieve that easier compared to that last piece, that is your seed to seed spacing. And that probably is where that seeding rate comes into play, right? If we're planting at such a high rate, we are putting seed on top of each other anyways. So optimizing seed to seed spacing, that singulation, might not benefit us as much anyway. So maybe cutting down on the seeding rate is a good beginning point there. And then hopefully we'll move forward to the technology that gives us that ideal singulation at those high seeding rates, right? That is the issue, that the technology is not built to plant at those high seeding rates. And hopefully if we lower that seeding rate, that will help us in that aspect.
Hey, thanks, Manny. We have a couple quick questions coming in. First one, what type of down pressure is being used on each planter?
That's a good comment. Dennis was the one who was helping us plant these trials. Dennis, are you on the call? Can you answer that quickly?
Yeah, sure. I'd be happy to answer that. So in the planter that we used on this trial, this was a monosum planter, and it had their monoshock. It's just a spring-loaded down pressure system. It did not have any kind of hydraulic down pressure or down force other than just a standard spring in like a shock absorber type thing. But that is something that is a good question that we may want to think about, especially if we're going to continue to try to plant at high speeds, and it may be even more important in no-till type situations as well. But that is something that we need to be looking at for the future.
Yep. And that's what Dave was talking about, right? I mean, this is probably where I think we can try to separate the seeding depth from the seed to seed spacing and see what benefit we get just by controlling depth. All right. Any other questions?
Yeah, there's another one, and I don't know whether Dennis has this one too. Is there any planter now available for the 5-inch row spacing? And the same person's asking the second question, can the narrower 5-inch spacing make any difference in wheat maturity?
Yeah, so we are taking notes on the maturity for sure, and we'll have some data. We are trying, I think this year we try to be careful, at least noting that flowering time, and we did not see many differences. So at this point, at least for flowering, we haven't seen. We'll see again in terms of the physiological maturity. We'll try to take some of those notes. And in terms of the planter available, I know we were able to, I think Dennis was able to work with some counterparts in Europe, and we had that Horch planter / drill that plants at 6-inch row spacing, right? Dennis, I think there's an Amazon drill that plants at some narrow row spacing.
Yeah, for now, there's not much in the marketplace here in the U.S. designed for planting wheat that are on the ultra narrow row. There are some European planters that are out there that you can get your hands on, but there's not much available here in the U.S. market right now. We do have that prototype planter from Horch, and I know there's a guy up in the thumb that has an Amazon, which that's on, I want to say 5-inch centers or 10-centimeter row spacing. So that's even a little bit more narrow than what we have.
Yep. And we're thinking about taking this to on-farm, right? So if somebody is interested in maybe hosting one of these trials, Dennis and I will be talking about the next step for this project. So do let us know if you are interested. And my information is right here.
Well, thank you again, Manny and Dennis. We do have a couple more questions. We don't have time to get to them, but we will try and get answers back to those people. There are good questions, but we need to be moving on. So
all
next
right.
we